So hello everyone, welcome back. So far we have seen what is reactive programming, then we saw how to create a starter project of Vertx. Now before starting and deep diving into application developing, we should understand some core features of Vertx. So one of the fundamental features or fundamental block of Vertx is called verticle. Okay, so question is, what is a verticle? It's a basic building block of any Vertex application. It contains your business logic. It takes the responsibility of running your defined logic in async fashion internally. Thus, we as a developer need not worry about any kind of async implementation or even implementation explicitly. Verticles takes care of it. We can deploy multiple vertical in our Vertex application. Each vertical can communicate with each other through something called as event bus. Okay, we deep dive later in what is event bus in the next upcoming sections. But as of now, you can consider event bus is like a central nervous system, where through which the verticals can communicate with each other within an Vertex application. So let's see how exactly your application looks like in Vertex. Let's say this is your application. Okay. This is your application. Now, as I mentioned, there can be multiple verticals present in an application. Say for example, this can be one vertical. Okay, this is another vertical, and this is another vertical. Okay, and there can be many more. Let's give some nomenclature to this. Say V1, V2, V3, and say Vn. Okay. Now each vertical is associated with something called as event loop. Now if you remember, I discussed in the reactive programming section, there is something called as event loop. So what is this event loop? So this event loop is basically takes the responsibility of running your task or events that you define within your each verticals. Like you can define multiple tasks which are in turn called as events. So these events, each events are actually executed in something called as event loop. Okay, let's say EL1. So vertical 1 is has a dedicated event loop called as EL1. Okay, similarly vertical 2 will have its own dedicated event loop. Okay, EL2. Similarly for vertical 3, that EL3. Okay, event loop, and then this vertical n also will have event loop n. So now the question is, how many such event loop can we have in our application, right? So as per the official document of Vertex, it said that maximum number of event loops can be twice the number of cores in our system, okay, where the application is running. Apart from this, one thing we should keep in mind or understand is that every vertical is associated with a dedicated event loop, as it is responsible in managing all the different events defined within the vertical. Okay, now what do I mean by managing? What it has to manage? So basically it's not a straightforward thing, as if you remember what we have discussed in reactive programming. Say suppose if this is the event loop, okay, say EL, and we keep, suppose if it is empty, it has nothing to process, and the first task that comes up is say T1, this task. If it's a simple task, that is say adding up of two numbers, then it will get processed. Now another task comes say T2. Now it is say whatever sum you have added, you have to publish it in a database table. Okay. Now this is basically, this is nothing but a call to a database. Now this is not a straightforward call, so it has to send a request to a DB, and it may take, DB will in its end will take some time to respond back. Now during this time gap, in this time gap, obviously event loop won't get hung up. What it will do, rather it will park this task in the background, okay, and it will proceed with the other tasks till it gets any response from the database. The moment it gets response in the database, it will get queued up for further processing. Okay, this task will get queued up. So this is, so event loop takes all the responsibility of managing all the event in its asynchronous strategy, whatever it has to follow. Okay, we as a developer need not worry about all the minute details of its processing steps. Now having said all this, there are two type of verticals. One is standard vertical, another is worker vertical. Okay, what are the key difference? The first key difference is 1 minute. Yes, the first key difference is, it's like when we instantiate the standard vertical, it is assigned an event loop to process all the events. Okay, whereas in worker vertical, when it is get instantiated, is allocated a thread from worker thread pool. So what's the difference? Difference is, one of the key properties of event loop is that it's a non-blocking operation processing. Okay, so event loop should not get blocked. So what does that mean? That means no event, say in an event loop, no event should take more than 2 seconds of time to process. Okay, if it's taking more than 2 seconds of time, it is termed as event loop is blocked. Okay, because event loop is not expected to get blocked. It is supposed to pick up one event, process it, and if there is something, some response we're expecting in return, then we keep it, then the event loop will park that event in background till the response comes back, and in that meantime it will process other events, and continuously to keep on doing that. And the moment it receives some response, it will again put that event back in the queue. Okay, but in worker thread, the expectation is, if a task it's required a significant amount of time to process, it will allocate that much of time, or it will wait for the task to get finished first, so it won't complain. Okay, but in the standard vertical, the event loop starts complaining, because the main principle or the main fundamental of reactive programming is that the thread should not stay waiting. Okay, thread should always be processing one or the other event. Okay, but in this case, if it's it is possible that a thread is like, say, this event got processed, and then this time it is like waiting for something, and then another event is getting processed. So even if the thread is like waiting over here, it is not an issue. But in standard vertical, the event loop should not get blocked or should not be waiting for anything. Okay, so that's the key difference between these two verticals. So regarding this stat, now it is set 2 seconds ideally. Okay, but you can change this stat, maybe make it to 4 or 3, but as it's a suggestion that need not change the factory setting or the default setting of the timeline, because if it's really taking more than 2 seconds, then it's a matter of concern. because in real world scenario we generally try to respond back within milliseconds. Okay, and it's a key fact. It has been found that if suppose an API is responding in say 400 milliseconds, or basically it's taking time of more than 200 milliseconds to respond back, then users start feeling a lag in the response. So those who are like more focused in giving a smooth user experience, they try to keep the response time of an API less than 200 milliseconds, and this response time involve uh, intercepting request, processing the request, sending some metadata to database, or receiving some metadata from database, and then eventually sending out response. All these things should get completed within less than 200 milliseconds. So with this perspective, if your one event itself is taking 2 seconds of time, then it's a matter of concern. Then probably we should allocate this kind of task to worker thread only. And seeing this kind of possibilities, Vertex has given us the feature of worker vertical. So these are the basic concept that everyone should know before starting with Vertex, especially with the vertical. Now there are many more detailed things that are there for vertical, like if we go into the official site, that is in vertx.io docs. So you can see there is a section for vertical. So in the left hand side you can see there is a vertical section, and in this vertical you can see far more details are over there. Now if you remember, in the last video we saw that we are extending this abstract vertical, right? So abstract vertical is a kind of a signature of a vertical, and whenever we are creating a new vertical, we should extend this particular class. Okay, this is a you can say parent class for a vertical. Okay, and then we should override the start and stop method. Now what is this start and stop? So start, as it suggests, is like it's just beginning, how you want to start the vertical, or what all things you want to do in the vertical, in what fashion, in what sequence, and in what logic. So all the business logic of your requirement should get described within that start. Okay, and accordingly it will get, and whenever we deploy the vertical, this start method will get called up, and then whatever logic we define within the start, those will keep on getting executed. Okay, we will look in a far more detail in the next video as we start the hands-on. Okay, and similarly this is the stop one. Stop one, I suggest, so whenever if we are trying to kill this vertical, then at that time the stop gets called, and then within that stop also we can do something. Okay, so apart from that, what we have, so it's like asynchronous vertical start and stop. So we can see over here how to do that. So they have given the code snippet also. So we'll explore all this one by one. So we have gone through vertical types, standard vertical and worker vertical. Okay, so you can go through these sections further. This is like how to create a worker vertical and all. Okay, now deploying vertical programmatically. So how are vertical factories located? So a lot more things are there. Okay, you can go through this for further details if you have if you want to explore what are possibilities we can have, or we have in the Vertex with the vertical. You can go through this documentation. So that's all for now for vertical. Let's catch up in the next section with the hands-on.